and welcome back to our track, which is about OpSec Welcome back. Now, I don't know if you went to the yoga class or to the quiz. I went to the quiz. I would just like to say I got all of the questions right, but I did struggle. I was thinking about the Kubernetes release date. I had to rack my brains and I had to guess the coffee pot protocol, but I got that right. 100%. I don't know why I didn't appear on the leaderboard. Now, following on from the quiz, we have Timothy Mamo. Timothy is going to be talking about how your infrastructure needs to die. Timothy, welcome to WTF is SRE.
Thanks, Jamie. Good to be here.
You are live. You have shared your screen. You can speak.
All right. Okay, so off I go. So hi, and thanks for joining me. As Jamie said, I'll be talking about how your infrastructure needs to die. Yeah, ominous, I know, but you don't need to be scared, even though I look like this. But before I go into that, I'll introduce myself. As we said, my name is Tim, and I'm a platform engineer with Skyworks, which is a boutique consultancy company that enables other companies leverage cloud technologies by helping them shift their mindset into a cloud-native way. So my presentation is split into two parts. We'll first go on a diamond heist, and I'll be relating the story to the current, or should I say old, principles of InfoSec. After our heist, I'll go into the D.I.E triad, and I'll sprinkle a little bit of chaos to it. So our heist starts in Antwerp, Belgium. And yeah, by the way, this is an actual based on an actual story. As I said, we're in Antwerp. It's the beginning of 2003. And we've got a team of 6 people. Starting off, it's the genius, the one who specializes in alarm systems and can disable any kind of alarm. Second up is the monster. Huge, tall man, is monstrously good at everything he does. He's an expert lockpicker, he's an electrician, he's a mechanic. You name it, he can do it. There's the king of keys. This guy's old man, but he can replicate any key in the world. We've got the insider, who's an Antwerp diamond dealer, and there's Speedy, the fidgety one. But he's friends with the mastermind. And the mastermind himself, not our Bartolo, he's the suave Italian man. So our target is a vault 2 floors beneath the Antwerp Diamond Center, filled with about 160 safety deposit boxes, which customers are allowed to come and see during office hours. The vault itself is protected with multiple security systems. There is a 3-ton vault door, and there's a lock with 100 million possibilities and a seismic sensor. There is a keypad which disarms all the sensors. There's a magnetic sensor, a infrared heat detector, security cameras, and a light sensor. The building itself also has a private security force. So the target, the vault, is following InfoSec's key principles of CIA. Confidentiality. Only authorized people are allowed to enter the vault. Only a select few have the knowledge of the dial combination on the vault door and know the code to the keypad to disarm all the sensors. Integrity. The vault door is made of a 3-ton steel system and is 2 floors below the Antwerp Diamond Center. And finally, availability. I mean, they allow the customers to go to the vault, supervised obviously, and open their safety deposit boxes. But our team is fairly ingenious, and tackling these problems is no issue. Notar Bartolo has disguised himself as a diamond merchant, and over a few months, he's gained the trust of the security there. This allowed him to place several small cameras around the vault, which meant we could find out the combination through the footage of the cameras. He also sprayed some woman's hairspray on the thermal sensor the day before the robbery, disabling all the sensors until they were styrofoamed. The heist was planned for the weekend, when the private security force was back home resting. And access was gained through the back garden of the building next door. The security cameras were covered with black plastic bags. The magnetic field sensor was easily fooled by placing an aluminium sheet on one side and unscrewing the other and duct taping the two together. The King of Keys had actually created a duplicate of the key for the vault door, but footage on the cameras actually showed us the security guards leaving the actual key in the utility room nearby. So yeah, this true story has allowed the burglars with some very simple tools and a lot of ingenuity to disappear with 100 million euros. So why am I telling you the story? What does all of this do for us, our industry? Well, it shows us it's difficult to outfox a fox. Hackers will keep on improving on their abilities and skills, and are usually fairly persistent in wanting to hack you, especially if they're going to place a crypto miner or threaten you with some ransomware, as we've recently seen. Vulnerabilities are never ending. There's always some CVE, and hopefully there's a patch in place which we can implement immediately. Plus, mistakes are done and overseen. The security force got lax as they got accustomed to Notar Bartolo and let him place the cameras and spray the thermal sensors. So how do we tackle this problem of continuous hacker improvement? Well, as we move towards the cloud and use tools provided by the cloud providers, we need to shift our mindset. We need to be more cloud native. And we can do this by ensuring that as much of our infrastructure adheres to the D.I.E triad: distributed, immutable, and ephemeral. It was first proposed by Sunil Liu and championed by InfoSec experts like Kelly Shortridge. So first off, distributed infrastructure. Well, imagine had the 100 million euros being distributed over 100 million vaults all around Antwerp or all around Belgium. The amount which would have been stolen would have been a lot less. Now with cloud, we don't have the issue of having to go through the process of actually building 100 3-ton vault doors and placing them all over the country. But we can spin up the same server, the same cluster, the same Docker container 100 times with a click of a button. Or, if you're doing it correctly, with one line of code. And you want to do this because, as the saying goes, you don't put all your eggs in one basket. If your system is distributed over a number of VMs, availability zones, regions, or even maybe cloud providers, you're ensuring that your system is highly available, redundant, and fault tolerant. There's no single point of weakness in your system. If one server goes down, I've got 99 servers, but this ain't one. And I promise you that's the last bad rap lyric I'll be giving this presentation. Content delivery networks, CDNs, have made the outcome of DDoS attacks a thing of the past. They also ensured that networks stayed online when coronavirus caused the pandemic and pretty much shut down the world, having everyone log onto their computers pretty much simultaneously to do their work. Container Solutions, the organizer of the conference, actually has a great blog about this by Anne Curry. I hope I pronounced that correctly. CDNs have managed to leverage that cloud native mindset by ensuring the attack and brute forcing events by the thousands of bots cannot be concentrated on only one direction, on only one server. And you also have the benefit that if an attacker does decide to go for that one server, all you need to do once you're notified about that crypto miner, which is costing you a bit, is shut it down. The ability to randomly destroy a server, knowing with confidence that your services are still up and running, is going to be a nightmare for attackers. Next up, immutability, the process of not changing anything on your server or container or system once it has been deployed. So there's no SSHing, there is no kubectl exec, and there is no writing to disk. And I can pretty much hear people shouting at me from the screen going, what? How? Well, yeah, there's none of that. Once it's deployed, you do not touch it. Taking our heist story as an example, if some of the safety deposit boxes had been wired to be triggered as soon as they were touched, you'd automatically lock the 3-ton vault door and call the security forces. I'm sure you'd have a fairly disgruntled robber once you reopen the vault. Ensuring that nothing can be changed once it has been deployed means that any changes that occur are easily monitored and detected. And because you're versioning all of your infra code, right? You're all versioning it. You can easily revert back. This means you don't need to allow shell access, as nothing should be changed. If there are no doors and windows, it is fairly hard to get in. You've reached security nirvana. Creating immutable infrastructure means you're starting to treat your servers as kettle rather than pets. I'm sure we've all heard about the kettle pets analogy. And any upgrades that need to be done, yeah, you create a new image, you deploy it, you reroute the traffic to it, and you delete the old one. You need to log something new, something extra, you create a new image, you deploy it, you reroute traffic, and delete the old one. The new image you've just deployed is buggy and not working. Yep, you've guessed it. You don't need to create a new image. You deploy the old one, reroute the traffic, and delete the buggy image. This is being done with Kubernetes on a daily basis, if you're doing this correctly, with containers. Once you've got a bug in a container, you don't kubectl exec and look around the container. Well, at least you shouldn't be. If you want to change code on that container, you don't exec and change the code. You build a new container, you deploy it, Kubernetes will automatically reroute traffic to it and destroy the old container. All we need to do is shift that mentality towards servers, VMs, the whole cluster. The process of upgrading a cluster should follow immutability. When changes are not allowed, you can easily fool attackers. Or as Kelly Shortridge puts it, implementing the bamboozle layer. And I love this. I think this is a great concept. I mean, every company should implement the bamboozle layer, even just for the sakes of having something called the bamboozle layer. I mean, imagine having a do not touch TXT file or passwords TXT file filled with gobbledygook stored in the home directory on your server. Obviously, this is something enticing to a hacker as he accesses your server. But you've set up the server to, boom, disappear, destroy as soon as the hacker touches that file, leaving your attacker dumbfounded. And because your infrastructure is immutable, you can automatically redeploy that server, in essence, creating self-healing servers. So no more midnight emergency phone calls, and who doesn't want that? And finally, ephemeral infrastructure, short-lived infrastructure which serves its purpose and then dies. And the emphasis here is on short-lived. I mean, had the location of the vault lived for a very short time and then been changed after a few days without any major planning, a team of bandits wouldn't have been able to take months to plan their heist. And again, cloud allows us to do this a lot more easy than having to move physical vaults in different locations every few days. You want your infrastructure to be immutable, as that makes it even more difficult for an attacker to plan and ensure that his attack is constantly pointed on that server. As the attacker is uncertain whether or not your infrastructure will die at any moment, it's going to be a nightmare for them to plan the attack, giving them a very short window to actually do the attack. They want to be certain that the time spent on trying to get on your server, installing that crypto miner, is worth it and won't disappear within the next few seconds. So don't make it easy for them. So designing for ephemerality pushes you to design your applications to be stateless. Knowing that your application can die and disappear at any moment means that you cannot and should not and don't want to store state. And not storing state means that your attacker has a harder job at trying to extract the data or the token from you. And talking about tokens and passwords, you not only want your infrastructure to be ephemeral, but you also want to ensure that your passwords and tokens are ephemeral. So even if the attacker has managed in some way to extract the tokens from your application, they're short-lived. They cannot be used after a few minutes. Having your infra die after a short amount of time, but your application is still using the same secret over and over and over again. Anybody thinking of username and passwords for databases? That system is pretty much a hollow measure. Tools like HashiCorp's Vault and AWS's Secret Manager, which will rotate passwords for you, can help. I mean, if I take, for example, my two-factor token, which I hope you can see and showing you right now. And I know this will live forever. It's on the internet, it's being recorded, and it's going on the internet. I know that that token is short-lived, it's ephemeral. That's not an issue. Okay, you need my password as well, but I haven't gotten around to creating ephemeral passwords. Plus, I don't know my password because I'm using a password manager, but you kind of get the gist. So in designing your infrastructure to be distributed, immutable, and ephemeral, in essence, following the D.I.E triad, will incorporate security inherently. And the old principles of CIA, confidentiality, integrity, and availability, can be ignored. As Sunil puts it, if my system is distributed, why do I need to worry about availability? If my infrastructure is immutable, why do I need to worry about integrity? And if my system is ephemeral, why do I need to worry about confidentiality? Now, it's all easy for me to stand here and tell you, design your infra to die. Design it to be distributed and immutable and ephemeral. But what if you've got systems up and running already? You've probably got some pets. Well, create some chaos. Now, I'm not going to go into the details here of chaos engineering because that's a whole different talk in and of itself, and I'll do that maybe another time. But implementing chaos engineering or creative destruction allows you to improve on your current system. It shows you what happens to your system when things do go wrong. It also tells you how well do you know your system. Does it react the way you think it will react when things go wrong? But a hard requirement for doing chaos engineering, and this is a hard requirement, is monitoring and metrics. You need to implement monitoring and metrics. Without monitoring and metrics, It's like the clueless leading the helpless. I've seen too many companies not focus their energy on monitoring and metrics. So as you do chaos engineering, you'll find the pets that really want to change the cattle and configure them to adhere to the D.I.E triad. Because as I've hopefully have convinced you, supporting infrastructure that is ready to die is a lot easier. But before I finish, I want to answer the question, do I need to do everything? Is everything, I'm going to do everything all at once? Well, obviously, the answer is no. You don't start shutting off systems and releasing your monkeys in production without any planning. You could start slowly in the staging environment. Make sure you do some planning before you actually implement chaos engineering. Does everything in my architecture need to be part of the cattle? Well, let's be realistic. Especially if you have systems which are already running, you'll have pets. If you understand and question how those pets are affecting you and how it will affect your security, resilience, and availability, and if you're not happy with how you've answered that question, well, then start planning to move those pets to cattle by shifting them to be more distributed, immutable, and ephemeral. Bonus points if you've gotten the Hitchhiker's Guide reference over there. So in conclusion, the more your infrastructure adheres to distributed, immutable, and ephemeral, the D.I.E triad, the lower you are allowing your infrastructure to impact you. And therefore, the lower the risk on your system. In essence, as the slide is showing us, you can be as snug as a cat in a blanket. Thanks for listening to the talk. I'd love to hear your views and opinions on my talk, and I'm more than happy to answer any questions.
Jamie, you're on mute again.
I can't believe it. I've done it again. Thanks, Kerry. Well,
after a year of pandemic, you'd expect that the...
Oh my
can you hear me?
Yeah, we've gotten so used to doing this, both at the company and with our customers, but it's the end now. Please make it be the end.
Yeah.
Timothy, really nice talk. Beautiful visuals, by the way, in your deck.
Thanks.
Yeah. No worries. Okay, Carrie, how are we doing on the questions?
Yeah, we have some questions. Alexander has asked, can you comment on the trade-off between security and performance, needing to read and write state to external system? And then second part, options, middle grounds.
Sorry, I didn't hear the second part.
Second thought, options for that and middle ground options.
So between security and performance, I don't think there needs to be a performance deterioration in your security. Actually, having distributed systems can help your performance. Having immutable infrastructure, for example, knowing that you're not changing them, and you're shipping your logs to a different state, an external state, can actually help with the performance. There might be some latencies, but again, according to how you architecture your system, if everything's on the same VPC, it will be in microseconds or milliseconds to ship those logs. With regards to options, so as I said on my last few slides, I am realistic. I'm trying to achieve the ultimate state here, but I do accept that everything being D.I.E is probably not possible. Databases are usually the common question here. My database needs state. Well, actually, the server of the database doesn't need state. It's the underlying data that needs to remain there. What you could do is give all that work of making your database immutable and ephemeral to AWS. RDS instances, for example, when AWS decides to upgrade, I'm sure the way they do this is through the D.I.E model. They don't shut down your database and then respawn something else. They upgrade it, reroute the traffic, and then shut off the old version. So I think with regards to options, be realistic. I mean, yes, manpower obviously also makes a chance. If it's just you and you yourself, the process is probably going to be a lot slower. If business is shouting cost rather than security or performance, that's a business thing, but obviously distribution can be a bit limited. So it's taking reality also into effect.
Right. Awesome. I have another question here from Kurt. I talk with companies who have low latency requirements, like less than 10 milliseconds, and they use this as a reason to avoid Kubernetes and to stay bare metal. How does one get around this?
Yeah, I've always found the bare metal versus cloud discussion a bit mind-boggling a bit to me. Because at the end of the day, and even though, is it Martin Skelter who tweeted recently, cloud is not somebody else's computer. It kind of is somebody else's computer. There are still servers. So bare metal, it's AWS's bare metal. The fact that the company has bare metal infrastructure doesn't mean that you should be allowing everybody to that bare metal. So yeah, this is a difficult one to answer, because to me it's obvious that just because you're on the cloud doesn't mean you're losing amounts of latencies. You can actually make it quite short if you've got everything in the same VPC. If you're doing multi-cloud, yes, there might be some latencies, but again, multi-cloud is a very specific area, and that's when your organizations are huge. Small companies, I believe, shouldn't be focusing on multi-cloud. The other thing I'd say is your answer Kubernetes, is the solution Kubernetes the right thing for the customer? I think Kubernetes is a great tool. I love Kubernetes. I mean, I've got the CKA certificate, but look at what the business and the customer wants, and is Kubernetes the right thing to do? Yep.
Okay. There's a couple more questions, but I'm going to just stick with one more question as we're running a bit low on time. From working with this D.I.E approach, there's a question: are there any downsides of using this approach?
Well, the main downside is architecting, and actually creating the D.I.E system. Creating a system where you can spin up a different version with all your applications in it. Now, tools like Argo CD and Flux do help you if you're using Kubernetes, do help you do this, and then rerouting traffic with minimal downtime or no downtime at all is probably a lot more difficult than SSHing into a machine and upgrading. But again, it's a cost-benefit thing, where the amount of effort you're going to put in to create that system will allow you to be more secure and will allow you to be a lot easier in your upgrades. The one thing I hate about AWS's managed Kubernetes system is to upgrade. There's a sheet online and you have to go through steps, and you need to SSH into here, and you need to do this. I mean, for starters, that's not really a managed system. I'm not going to go on that rant for now. But also, I'm on my toes of thinking, oh, am I going to break something? I'd rather spin up a new system, the new version of Kubernetes, which comes out every 4 months, reroute traffic to that cluster, and then shut off that one. But it's a lot more difficult to do that, yes.